So today we're going to be discussing angle relationships with our proofs. So we're starting out with our protractor postulate. So we have given that ray AB and a number r, and that r is between 0 and 180. There is exactly one ray with endpoint at A. Extended in either side of AB such that the measure of the angle formed is r. Okay, so here's what we have. We have ray AB right here. It's going in this direction. We have some number r that's here. It's between 0 and 180. There's exactly one ray with an endpoint at A that extends in either side of AB such that the measure of the angle formed is r. There's only one ray, one possibility to get this angle measurement. Okay? So then the next one that we have our angle addition postulate, so very similar to our segment addition postulate. Now we have if r is the interior of angle PQS, then we have the measure of angle PQR plus the measure of angle RQS equals the measure of angle PQS. So it's saying if r is inside of this big angle, then we know if we add these two small ones together, we're going to get the big one. Okay, so then we have an example here. So if we have the measure of angle ABD equals 40 and the measure of angle ABC equals 88, then we're going to find the measure of angle DBC. Okay, so how do we do that? So we can use our proofs here, our two-column proof, so our statement and our reason. So again, we're going to start out with our given. So we have A, B, D equals 44, and that's an angle. And we have the measure of angle A, B, C equals 88. That was given to us. So then the next thing that we're going to do is we're actually going to start putting some things together with our angle addition postulate. So we have the measure of angle ABD, okay, plus the measure of angle DBC equals the measure of angle ABC. Okay, and that is angle addition. Alright, we took two smaller angles. They have a common ray, this BD, in order to get the bigger one. Okay, so then the next thing we're going to do is some substitution here. Substitution for ABD, we know that that's 44, so we're going to put 44 in there, plus the measure of angle DBC equals ABC, we know is 88, so we're going to plug 88 in there for that. Okay, so then the next step that we have, I'm actually going to subtract 44 from both sides, so that's subtraction. So then I'm left with the measure of angle DBC equals 44. So we found the measure of angle DBC, it is 44, and this is substitution. Okay. Alright, so let's look at some more stuff here. So we have a couple more theorems that we're going to look at. So our supplement theorem, this is 2.3. If two angles form a linear pair, then they are supplementary angles. And if you remember, a linear pair means a straight line. So this is a straight line. Okay, that's what a linear pair is. Alright, so if they make a straight line, then they are supplementary. And supplementary is 180, so if you look at the picture here, if they make a straight line, a linear pair, then we know when we add those together we should get 180 degrees. Okay, the next one is complement theorem. This one is telling us if we have the non-common side of two adjacent angles. So adjacent, if you remember, that's side by side, not overlapping. Then they form a right angle. Excuse me. And they form a right angle, then they are complementary to each other. Okay? So if the non-adjacent sides, that's this outside side here and the outside here, if those form a right angle, then these two angles are complementary. And if you remember, complementary means they add up to 90. So angle 1 plus angle 2 gives us 90. Alright, so let's look at another example then. So for this one, if angle 1 and angle 2 form a linear pair, and the measure of angle 2 equals 67, we're going to find the measure of angle 1. Alright, so we're going to start out with our statement, which is our given. So if we have angle 1 and angle 2 form linear pair, then my reason is that is given. And I also have the measure of angle 2 equals 67 as part of my given. Okay? So then the next thing I'm going to do is I'm going to use my definition of linear pair. Because the definition of linear pair means that it's a straight line, right? So definition of linear pair, I have the measure of angle 1 plus the measure of angle 2 equals 180. Okay, because that's what we said right up here. If they're a linear pair, we add them together, they equal 180. Okay, so then we come back down here. So the next thing I'm going to do, I know that the measure of angle 2 is 67, so I'm going to plug that in. Measure of angle 1 plus that 67 equals 180, so that's substitution. So in the next step here, I'm going to subtract 67 from both sides, so that's subtraction. Alright, and then I'm going to simplify. The measure of angle 1 equals, so this is substitution. So what do I get here? I should have 113. 113. And so it asked me to find the measure of angle 1. Well, I just found the measure of angle 1 is 113 degrees. Alright, let's look at one more. Now we have our angles supplementary to the same angle or two congruent angles are congruent. So this is 2.6. So we have two angles, angle 1 and angle 2, that are supplementary. And angle 2 and 3 are also supplementary, so they're both supplementary to angle 2. So then we know that 1 and 3 are congruent to each other. Okay, that's the example I have right down here. So if we know angle 1 plus angle 2 is 180, angle 2 plus angle 3 is 180, then we know that angle 1 and angle 3 have to be congruent. So our abbreviation for that is angles supplementary to same angle or congruent angles are congruent. So depending on which one of these applies to your scenario, you only have to write one. So then 2.7, this is with complementary ones. So angles complementary to the same angle or to congruent angles are congruent. So same thing, but now we're dealing with complementary. So if we know that 1 is complementary to 2 and 2 is complementary to 3, then we know 1 and 3 have to be congruent to one another. And again, here's your example and your abbreviations. Angles complementary to same angle or congruent angles are congruent. And here's the example that I just went through with you. Alright, so let's keep moving. So we have another proof here. So our given tells us angle 1 and angle 3 are complementary. Also that angle 2 and angle 3 are complementary. And that was given. Okay. and we're trying to prove that angle 1 is congruent to angle 2. So how are we going to do that? Like I said, first we have our given. Then our next step, we're going to be using that definition of complementary angles. So what does it mean to be complementary? If we add them together, we should get 90. So the measure of angle 1 plus the measure of angle 3 equals 90. And the measure of angle 2 plus the measure of angle 3 equals 90. Okay? So then our next step here is we're actually going to substitute. So we're going to take this 2 plus 3 and we're going to plug it in for the 90 since we know that it equals 90. So the measure of angle 1 plus the measure of angle 3 equals the measure of angle 2 plus the measure of angle 3. So that is substitution. Alright, so then the next thing that I'm going to do here is I'm actually going to use my reflexive property. So we know that the measure of angle 3 equals the measure of angle 3. That is reflexive. Okay, so since I know this, oh, I am so sorry, let me scoot that up for you. Since I know that these are equal to each other, I'm going to subtract those from both sides. So I'm going to subtract the measure of angle 3, subtract the measure of angle 3, so that's going to be subtraction. So I'm left with the measure of angle 1 equals the measure of angle 2, and that is substitution. Okay, so I just subtracted here and then subtracted on that side, so it left me with the 1 and the 2. Okay, and then the last piece, since they wanted to know that they are congruent, I'm going to use my definition of congruent. So the measure of angle 1 is congruent to the measure of angle 2. Okay, great job. Let's move on. Here's another one for us. So now this time we're given that angle 1 and angle 2 form a linear pair, angle 2 and angle 3 form a linear pair, and then we're trying to prove that angle 1 is congruent to angle 3. So again, we start out with our given. Angle 1 and angle 2 are linear pair. Angle 2 and angle 3 are a linear pair. And that was given. So then the next thing that I'm going to do is the supplement theorem. Okay, so with our supplement theorem, we know if they're linear pairs that they are also supplementary. So angle 1 and angle 2 are supplementary. Angle 2 and angle 3 are supplementary. Okay. So then the next thing that I'm going to do here, if those are supplementary, then I know angle 1 plus angle 2 equals 180. Definition of supplementary. Angle 2 plus, angle 3 equals 180. Same reason there. So then from here I'm going to do substitution. Angle 1 plus angle 2 equals angle 2 plus angle 3. This is substitution. Now I can see I have an angle 2 on both sides, so I'm going to subtract those. And then that leaves me with angle 1 equals angle 3. Substitution, I simplified. And then the last piece, they want them congruent. So angle 1 is congruent to angle 3. definition of congruent. Okay? Great job. Now let's look at our vertical angles. Take a look at our vertical angle theorem here. So vertical angles, if two angles are vertical angles, then they are congruent. And we have had that before, but now we're going to use it in terms of proof. So we know that 2 is congruent to 4, 1 is congruent to 3. Those are vertical angles. Okay? So we have an example down here. So we're going to be looking at that one. So if angle 1 and angle 2 are vertical angles, and the measure of angle 1 equals x and the measure of angle 2 equals 28 minus 3x, then we're going to find the measure of angle 1 and the measure of angle 2. So we need our statement and our reason. Okay, so our first one, we have our given, angle 1 and angle 2 are vertical angles. Measure of angle 1 equals x. Measure of angle 2 equals 228 minus 3x. These were all given. Okay? So then the next thing that we're going to be doing here is if these are vertical angles, then by definition, our vertical angle theorem, we can say that angle 1 is congruent to angle 2, and then definition of congruent tells us that angle 1 equals angle 2. Oh, I'm so sorry. Let me scoot that up for you. Okay, so I was just saying that angle 1 is congruent to angle 2 because of that vertical angle theorem that we had. So then we can change those to equal by definition of congruent. Okay, so then the next thing that we're going to do is actually substitute. We know angle 2 and angle 1. So x equals 228 minus 3x, and that was substitution. We just took these two pieces up here and plugged them in to our equation. So now we're going to solve for x. So we're going to add 3x to both sides. So that's addition. So we end up with 4x equals 228. That is substitution. So then our last step here to get x is we are going to divide by 4. So division. And when we divide by 4, we get x equals x equals 57. Sorry, I had to think about that for a second. X equals 57. This is substitution. Okay, so then we do have our x. X equals 57. They said to find the measure of angles 1 and 2. So we're going to come back up here to the top. So if we know that angle 1 is x, so we're going to plug in the measure of angle 1 equals our 57, and the measure of angle 2 is going to be 228 minus 3 times the 57. So when we actually work this all out, we should get the measure of angle 2 also equals 57. Okay? Alright, so then the last little bit here is just some more theorems. These all have to do with right angles. Okay, so our right angle theorems, you're just going to be copying these down. So 2.9 is perpendicular lines intersect to form 4 right angles. And we know that, we've talked about that before. 2.10 is all right angles are congruent. Obviously, if it's a right angle, it's 90. Every one of them is 90. 2.11 tells us perpendicular lines form congruent adjacent angles. Perpendicular lines form right angles, so that makes sense. 2.12 is if two angles are congruent and supplementary, then each angle is a right angle. Supplementary means 180, so if they are congruent, then they're each 90, which is a right angle. And 213 is if two congruent angles form a linear pair, then they are right angles. And again, a linear pair is 180 degrees. So if you have two congruent angles forming that, they have to be right angles. So that's all I have for you today. I know it was a little bit longer, but hopefully you were able to get all of that down, and we'll be talking about it in class tomorrow. Have a good evening. Bye.